And hello again guys, David here. Today I'm gonna be showing you my fast Fourier transform visualizer. What this thing really do, it visualize signals, and it also can initialize and generate signals by adding different signal terms to each other and creating a standard square, triangle or sawtooth examples. So let's start this thing. You first see this line here. What does it really do? Let's take that for example. There, so we have a wiper. This is the object that I'm creating. Every wiper has a bunch of harmonics inside it, so you can add a bunch of sine waves or cosine waves to a wiper, and inside the instance they're representing as radius vectors with amplitudes and initial phases and circular frequencies. So this here is the amplitude, this is the circular frequency, this is the initial phase and the time delta. For those who don't know what a circular frequency is, you may be familiar with the frequency of your TV or your household voltage. The circular frequency is related to the signal frequency by 2 pi times f, where f is the sine wave frequency. So here goes directly 2 times pi times f. This is in radians in a second, by the way. We're doing a delta of 0.1 seconds. So if we actually plot this, we will have a sine wave which creates only one vector with circular frequency of 0.005. This is how a sine wave can be represented. This is very nice thing to be used when visualizing a standard non-sine wave functions, which can be represented as a sum of different harmonics. Let's take for example the square wave. I have an initializer for it here, boom, like so. And its main harmonic, you can see it's 15 units long and have circular frequency of 0.02. I'm taking here 20 terms. So in this case I'm having the main frequency, which has those parameters, plus 1/3 of that with 3 times this frequency, and 1/5 of that with 5 times this frequency, and so on. Every odd number there, and this should be multiplied by 4 over pi. So if I take 5 terms, this will look a lot like a sine wave rather than a square wave. But we increase the terms, boom, it becomes more accurate as expected. Second thing I'm going to show you is a sawtooth initializer. Those harmonics and terms have alternating signs. So the first should be negative, then positive, then negative, and so on. And every term should be multiplied by 1 over the ID of the term. So you have negative sine of that phase, that amplitude and that circular frequency, plus sine of half over that and 2 times that, and minus 1/3 of that and 3 times that, and so on. And if we take 4 here, we have 4 on these terms. It rather looks like a sawtooth wave. If we increase the terms, as expected, becomes more accurate. Oh, 400. Oh, my PC is going to calculate this. This should be very, 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 very accurate. Like so. Let's try a different initializer. The last thing I'm gonna show you is the triangular signal, which can be represented by a again of sums of sine waves. Here we need this the count of the harmonics, which goes inside the formula. So this again has alternating terms. Oh yeah. -1 for that, and plus one over n squared, which is in fact this. And it has like again minus plus minus plus and so on. If we do 3 harmonics there, we have 3, so we should have 3 radius vectors, and we in fact have 3 radius vectors, as you can see there, a little long one and 2 little tiny ones. This is in fact the 1/9 of that. If we increase again the terms, it becomes more accurate. Boom. And the last thing I'm going to show you now is the random signal. So what do we do here? We take all those parameters for the main frequency and we're generating random numbers for each of those. For every those 50 terms we get those, and we multiply these by some random numbers, and this actually may seem chaotic at first, but this is actually a periodic function. You can say, why so? Because it's a sum of periodic functions. Simple as that. If we wait long enough, this radius vector should be connected to there, but I'm not going to wait for it to finish, because this will take very long time. If it goes dehydrate from thirst, it should feel free to pass out. So there. It's in factory. I hope you guys like my signal term plotter. I hope you also like my object-oriented way of doing this. And see you guys in a couple of days.